Now that you've warmed up with solving linear inequalities, let's move to polynomial inequalities. Unfortunately, you cannot treat polynomial inequalities like linear inequalities, where we pretend the inequality is an equal sign. That's just not how they work. The reason why we started with linear inequalities was to get your brain refreshed on what an inequality means, what that looks like, and now we're going to move into the polynomial stuff. Okay. We talked previously, earlier in last unit, about polynomial functions being above and below the x-axis. A couple of key sentences here. You want to recall that when a polynomial function is greater than 0, what that means is it's lying above the x-axis. It's positive, right? Greater than 0 means that something is positive. Similarly, when we're talking about less than 0, it's lying below the x-axis. It's negative. Okay? Less than 0 means it's negative. There's two ways to answer in a polynomial inequality questions. We're going to talk about both today. The first is to solve by graphing. Okay? We can either sketch by hand or we can use Desmos to create the graph and then interpret the answer at the end. For today, I'm going to be doing everything by hand, but I understand when you're doing your practice, if you just want to jump to Desmos, because the purpose of this is not to practice graphing, it's to practice interpreting the graph. Excuse me. Okay, let's do our first one. Let's determine when x squared minus x minus 6 is equal to 0. So what we're actually asking is, when is this below the x-axis? That's the question that's being asked here. So in order to figure that out, we need to figure out what our graph looks like. So we're going to factor it. I'm just going to rewrite our equation over here. And then I'm going to factor this. This is simple trinomial factoring. I'm looking for two numbers that add to -1 and multiply to -6. And the answer is -3 and +2. We can plot that on a graph with our two x-intercepts. So we have a +3 and a -2. My leading coefficient is positive, which means that it's going to be in a U shape here. And I'm not really concerning myself with how far down it goes. That doesn't matter for the inequalities. All that really matters is the x-intercepts. So let's go back to our question. Where is this graph below the x-axis? Well, it's below the x-axis, below the x-axis is here, right? So where is it below the x-axis? It is below the x-axis between -2 and +3. This portion of our graph is negative, okay? And so we can write that in two ways. It's below the x-axis. We can write it in set notation between -2, +3, or we could write it in, that's an interval notation. We can write it in set notation. -2 is less than x is less than 3. Recall that our question was asking simply less than. It didn't also have the less than or equal to. And so here I'm matching the symbol and I'm saying less than. When we do our set notation, or whatever this one's called, interval notation, I'm using the curved brackets because I don't want it to be equal to 0. At the points 3 and -2, my graph is equal to 0 because it is on the x-axis. So if I cared about that, if I wanted it to be equal to 0, I would need it to be a square bracket because they equal 0 at that point. They get really, really, really close to 0 at 3 and -2, so we leave them at the curved. Okay, simple question. Let's move on to a polynomial question here. Solve x cubed minus 5x squared plus 2x plus 8 is greater than or equal to 0. So what is this asking? Greater than or equal to 0 means above or on the x-axis. When does that happen? The only way we can do this is to determine where the x-intercepts are, so we need to factor. I don't know what any of my factors are, so I'm going to be using factor theorem to guess and check. Okay, let's check. X is, well, what are our options? Possible p-values are 1, 2, 4, and 8, and I'm getting those from my constant term. All of them can be positive or negative. Let's try positive 1. So we'll have a 1 minus 5 plus 2 plus 8. That does not equal 0. That's going to equal 6. Not that guy. Okay. Let's check. F is negative 1. That'll be negative 1 minus 5 minus 2 plus 8. There we go. That's 0. Negative 1 is a factor. And so x plus 1 is a factor. I'm going to use that now to do some synthetic division off to the right here. I'll write my coefficients and divide. Drop it down, multiply across. Add down, multiply across. Add down, multiply across, add down. Beautiful. So my factored form here will be an x squared minus 6x plus 8. And then I have to ask myself, well, can I continue to factor the x squared minus 6x plus 8? And the answer is yes. I can use simple trinomial factoring here. I'm looking for two numbers that add to negative 6 and multiply to positive 8. Those numbers are going to be x minus 4 and x minus 2. So our x-intercepts are going to be, we'll do these in green, negative 1, 4, and 2. That's where our roots are going to be located. Okay, let's complete a quick sketch here. So I'm going to add those onto my graph. We have one at negative 1, at 4, and at 2. All of these are degree 1, so they're just going to be crossing in a straight line. My leading coefficient here is positive, and I have a degree 3 polynomial, which means that I am headed from quadrant 3 to quadrant 1. And so let's create a sketch. Again, it doesn't totally matter how high or how low you go. What matters is the roots. So the question was asking, when is it above the x-axis, right? When is it positive? So this is above the x-axis. And when is our graph above the x-axis? Well, it's in two spots. We have this loop here. Maybe we'll do that in a darker green. That's above the x-axis, and that is above the x-axis. So there are actually two moments when our graph is above the x-axis or when it is greater than 0. The first one is going to be between negative 1 and positive 2. The second one is after 4, shooting off to positive infinity. Now recall that I also care about when it is on the x-axis, so when it is touching 0. So that means that I can change some of these curved brackets to positive brackets because I actually want my graph to hit those numbers. And we conjoin these, we say it is at both of these moments by using this little U symbol. It's like a capital U. This is union. U for union, and it basically means and. So at those two moments is when my graph is positive. Alternatively, I could write it like this. X is an element of all real numbers such that -1 is less than or equal to x, which is less than or equal to 2, comma, and I could just say x is greater than or equal to 4 because it goes off to infinity the other way. Okay, either notation doesn't matter to me, whichever one you're more comfortable with. So those are two examples where you have had to solve graphically. You were not provided the graph. You had to sketch the graph yourself using all of the prior knowledge and then interpret the graph and write a statement. The second way that you were expected to understand how to determine the intervals is by solving algebraically, okay? You always want to make sure when you're solving algebraically that you're starting in factored form. Just like when we were creating the graph, we wouldn't have been able to determine the intervals where it's positive or negative if we hadn't had the x-intercepts to then create the graph. So similarly, we are using our factored form in order to come to some conclusions here, okay? The very first step that you're going to do is you're going to determine the x-intercepts from our function here. So I'm going to set all of these factors equal to 0 and solve. And I just did that by rearranging. So we have 3 x-intercepts, we have -3, we have 5/2, and we have -1. Now to make things nice and simple for us, we're going to list the x-intercepts now in ascending order, so in increasing. So our smallest one, or our most negative one, is -3. And then I have a -1. And then I have 5/2, which is 2.5. What we're going to be doing now is we're going to be doing some tests, and we're going to be using a table to help us do these tests, okay? Some steps to help you create this table, and I'm going to get my ruler out to help, okay? You need to have one column per interval and one per x-intercept. So what does that mean? We need to have one per x-intercept, so I need 1 column, 2 columns, 3 columns, 4 columns, 5 columns, 6, 7 columns. There are 7 columns in total. 1 for everything before -3, 1 for -3. 1 for between -3 and -1, 1 for -1. 1 for between -1 and 5/2, 1 for 5/2, and then 1 for everything after 5/2. 7 columns in total. That's a lot of columns. One, two, three, 4, 5, 6, 7 columns. Okay, good. Now I also need 1 row per factor and a final row for the entire expression. So I have 3 factors here: x plus 3, 2x minus 5, and x plus 1. And I also need 1 more for the final expression, so I need a total of 4. Plus a header. Okay, now let's erase all this extra space. Okay. Now here's how we're going to fill it in, okay? We are going to, let's start off, the easier one is to put all of the factors, into our column on the left. So our factors were x plus 3, 2x minus 5, and x plus 1. I got them from the brackets in our question. That's directly where they come from. Now I'm going to fill in my x-intercepts, and I'm just going to skip one every time I do it. So our first x-intercept is at -3, -1, 5/2. The reason I skipped one is because now I also need to indicate the intervals. So for example, between -3 and -1, I need a column for that, which is right here. And the title for my column is just going to say, is going to be -3 to -1, anything within that range. It doesn't need to equal -1. We don't have a square bracket here because I've got a column dedicated to it. So we keep with the curved brackets. Let's do the second interval I have is between -1 and 5/2. And then with the end ones, that's where we shoot off to -∞ up to -3. And then our last one is between 5/2 and +∞. Woof. Okay, we've got all our columns in place. I'm just going to fill in my last row, and I'm going to write all of our factors multiplied together. Okay. Here's how we're going to fill this in. I'm just going to scoot this down so we've got some more space to work. What we need to do now, and I've got the instructions written on the next page, we now need to select values to test against each interval, okay? Basically, you need to pick any number in the interval. Then I'm going to fill in the table for each factor to indicate if it is positive or if it is negative. So, our first column is anything between -∞ and -3. Any number. I'm going to pick -5. -5 fulfills that. When I substitute -5 in to x plus 3, my answer is -2. It's a negative. When I substitute -5 into 2x minus 5, I get, that's -10 minus 5, I get -15, so my answer is negative. When I substitute -5 into x plus 1, I get -4, which is still negative. Okay, that's all we need to do. Our next one here, we're actually going to test the value -3. We're going to put that in. When x is -3, x plus 3 is actually equal to 0. When x is -3, 2x minus 5 is going to be -6 minus 5, -11. This is also going to be negative. When x is -3 into x plus 1, I get -2, which is still negative. Okay. Now we're faced with another interval. Now we've got to pick a number in between these two that's easy to work with. A number between -3 and -1, let's do -2. We continue our tests. If I sub in -2 into x plus 3, I'll get +1, positive number. If I sub in -2 into 2x minus 5, I get -9, which is a negative number. If I sub negative 2 into x plus 1, I get negative 1, which is a negative number. Alrighty, and the chart continues. I hope you can see the pattern and perhaps you can start working ahead without listening to me. Our next column, we have an exact value, negative 1. We've got to put that in. When x is negative 1, x plus 3 is positive. When x is negative 1, 2x minus 5 is negative. When x is negative 1, x plus 1 is 0. Alright. Next interval, I need a number between negative 1 and 5 over 2, which is 2.5. So I'm going to pick 0 because that's nice and easy. That's an easy number to work with. When I put in 0 into x plus 3, I get positive. 0 into 2x minus 5, I get negative. 0 into x plus 1, I get positive. And last but not least, second last, my last real x-intercept is 5 over 2, which is 2.5. Let's put that in. 2.5 plus 3, positive. 2.5 times 2 is 5 minus 5 is 0. 2.5 plus 1 is going to be a positive number. And last but not least, I'm going to pick a number for our last interval here between 2.5 and infinity. I'm going to pick 4. Doesn't matter. You can pick whatever number you want. Let's plug in 4. 4 plus 3 is a positive number. 4 into 2x minus 5 will be positive. And then 4 into x plus 1 will also be positive. We are almost done completing our table here. Next step. We need to multiply down each column to determine if the entire function is positive or negative on that interval. Here's what that looks like. I'm literally multiplying down. A negative times a negative times a negative gives me a negative. 0 times a negative times a negative is 0. A positive times a negative times a negative is a positive. A positive times a negative times 0 is 0. A positive times a negative times a positive is a negative. A positive times 0 times a positive is 0. Positive times positive times positive is positive. Bingo, bango, bongo. We have completed our table. Now we need to actually use this information to answer the question. What even was the question? We need to determine which intervals that fulfill my original expression. What was my original expression? What is this question even asking me? This question is asking me when my whole function is less than 0, or when it's equal to 0. When does that happen? Well, it's equal to 0 here, right? At all of the x-intercepts, it's equal to 0. That makes sense. The question is also asking me, when is it negative? Well, we've got a negative here, and we've got a negative here. So, we can use this information to write our final answer. Our function is negative between these two and between these three. What does that look like written out? Therefore, x plus 3 times 2x minus 5 times x plus 1 is greater than or equal to 0 on the intervals. The first interval is anything up to and including negative 3. Including negative 3 because it's 0 at negative 3, and anything before that because it's off to infinity here. So our first interval will be negative infinity to positive 3 inclusive. Union. Our second interval is anything between -1 and 5/2. Inclusive. Whew! That is quite a task, but rather simple once you get a hang of the method. Okay. Let's do a second practice. Solve x cubed minus 5x squared plus 2x plus 8 is greater than or equal to 0. Usually, you would have to factor this. Okay? Recall that this whole process of creating a table is impossible unless you are working in factored form. However, you may recall this is the same question that we graphed previously. So we have actually already factored it. This was our factored form. So I'm just going to copy that. I'm going to use this factored form. We're going to duplicate it and bring it on down, because there's no point in double doing the work. Okay, we need to know here where our function is greater than or equal to 0, where it is positive. Okay, what are our x-intercepts? Our x-intercepts are -1, 4, and 2. And we're going to rewrite them in ascending order. -1, 2, and 4. How many intervals do I need? 1, 2, 3, 4, 5, 6, 7. So I need, once again, a table with 7 columns. And I'll need one with 4 rows. One more. Perfect. Some space for a header. All right, let's erase what we don't need here. Okay, we are going to write our factors in. Our factors were x plus 1, x minus 4, x minus 2, and the whole thing, x plus 1 times x minus 4 times x minus 2. Our x-intercepts were -1, 2, and 4. Our intervals are between -1 and +2. And 2 and 4. On the ends, I've got here 4 going off to infinity, and on the left, I have -infinity coming up to -1. Let's start doing some testing. Okay, any number that's less than -1, let's do -2 and see. And fill this in. -2 into x plus 1 will be negative. -2 into x minus 4 will be negative. -2 into -2 into x minus 2 will still be negative. Overall, that puppy's negative. All right, next one. When x is equal to -1, x plus 1 will be 0, x minus 4 will be negative, and x minus 2 will be negative. Overall, when I multiply down, it's going to be 0. Next one. On the interval between -1 and +2, I'm going to pick the number 0. All right, x plus 0 into x plus 1 will be positive. 0 into x minus 4 will be negative. 0 into x minus 2 will be negative. Overall, this thing's going to be positive once I multiply down. Next one, I check against +2. +2 into x plus 1 is 3. +2 into x minus 4 is negative. +2 into x minus 2 is just 0. Oh shoot, I wrote a 3 instead of the actual number. positive, multiply down, and this ends up being negative. Sorry, 0. Okay, pick a number between 2 and 4. 3. 3 into x plus 1, positive. 3 into x minus 4, negative. 3 into x minus 2, positive. Overall, negative. When we have the x-intercept of 4, 4 into x plus 1 is positive. 4 into x minus 4 is 0. 4 into x minus 2 is positive. Overall, 0. And last but not least, pick a number greater than 4. I'll pick 10. 10 plus 1 is positive. 10 minus 4 is positive. And 10 minus 2 is positive. Overall, positive. So the question was asking, when is it greater than or equal to 0? It's equal to 0 at all of our x-intercepts, and it's greater than 0. It's positive right here. So I have this interval, and then I have going off to infinity that way. I can write my final answer. Therefore, x plus 1 times x minus 4 times x minus 2 is greater than or equal to 0 on the intervals -1 to +2 inclusive, because we want it equal to 0, union, and then 4 off to positive infinity with the curved bracket, 4 with the inclusive bracket, because we need it to be also equal to 0. Okay? In sum, we've seen 2 different ways: by graphing and looking at the graph, by creating an interval table. That's what this is called. This is called an interval table. You are expected to be to understand and be able to use both. On a test, I would specifically ask which method I want you to employ in order to determine where the graph meets these inequalities. Okay? Good work, everybody.